What I'm going to show you here is I wanted to show you an example of solving 3x3 systems and matrices using back substitution, but let you have a go at it as well. So I'm going to show you a question. I want you to pause the video, have a crack at it, and then come back and check your answer with the working I'm going to present to you. So here you go. So what I want you to do is use elementary row operations and back substitution to be able to read off the solution to this given system of equations. So pause the video and have a crack at that. So I've got my system of equations here. First thing I'm going to do is put them into an augmented matrix. So I'm going to end up with -2, 1, -1, 1, -1, 1, 2, 11, and 3, 2, 0, -4. Now what I'm going to do first is I'm going to do row 1 switched with row 2. Now the reason being, if I have a -1 here, what that's going to do is I can then multiply that up to get rid of the other variables easier. So what that's going to give me is literally just swap the rows around. -1, 1, 2, 11, -2, 1, -1, 1, 3, 2, 0, and -4. So now I can start getting rid of things. So if I do row 2, take away 2 row 1s, I'll eliminate that. And if I do row 3 plus 3 row 1s, I'll eliminate that variable there. So I'll end up getting, top row stays the same, -1, 1, 2, 11. I'll end up with 0, 1 take away 2 gives me -1, -1 take away 4 gives me -5, and I've got 1 take away 21, sorry, 1 take away 22 gives me -21. Bottom row will then become 0. I'll then have 2 plus 3 of those, so I'll have 5. Then I have 0 plus 6, I'll have 6. And I'll have -4 plus 33, that'll give me 29. What I can then do is if I do row 3 plus 5 row 2s, I'll eliminate this number here, and I'll keep this one as a 0. So if I were to do that, that would then give me the system -1, 1, 2, 11, 0, -1, -5, -21, and I have 0, 0. I then have 6 plus 5 of those, so 6 minus 25, so I'd get -19, and I'd then, excuse me, I'd then have this variable here, which is 29, plus 5 of these. Well, 5 of those is -105, so 20 minus 105 gives me -76 there. So what I'm going to do now is I'm going to take row 1 and I'm going to switch the signs. I'm going to do the exact same thing with row 2, switch all the signs, and row 3, what I'm going to do is divide everything by -19. Okay, once I've done that, what I'll end up getting is 1, -1, -1, -2, -11, 0, 1, 5, 21, and I'd have 0, 0, 1, and 4. So now I can start working back the way. So now if I do row 2, take away 5 row 3s, and I do row 1 plus 2 row 3s, I'll eliminate these numbers here. So do that down here on this line here, and I'll end up with my bottom row will stay the same, 0, 0, 1, and 4. Middle row will stay as 0, 1. I'll then take away 5 of these, so that'll become a 0, and I'll have 21, take away 5 of those, so I'll have a 1. Then I'm going to do the top row plus 2 of this bottom row, so I'll have 0, I'd have 1, sorry, -1. I'll then have -2 plus 2, which will give me 0, and I'll then have -11 plus 8, so that'll give me -3. Last one I can do now, if I do row 1 plus row 2, that'll eliminate this and give me my diagonal of 1s, with the rest being 0s that I'm after. So what that means is I can have it as 1, 0, 0, and then I've got row 1 plus row 2, so 1 plus -3, -2, so I'll then have 0, 1, 0, 1, and 0, 0, 1, 4. So now that I've got it into that format, I can quite simply read off my solutions. Just remember, this column's x, this column represents y, and this column represents z. What that means is I can say, fine, so x is -2, y is 1, z is 4. Quite simple, easy and straightforward as long as you remember how to do your elementary row operations. I would always suggest by starting to get a coefficient of 1 or -1 up here. It would just work better in terms of getting rid of the first column, and then you can see where you go from there. Straightforward, simple, just remember how to do the row operations.